Start. All right, to anybody at home, sorry about starting late here, but this is kind of how you would do this problem. Just set it up as the factors, multiply through, that'd be your answer. All right, let's take a look at, go ahead and just take a look at this one here. All right, if you take a look at the directions, it says find a polynomial equation of least possible degree whose with integer coefficients whose roots include the following. Key word, include. Okay, what that indicates is that there's another root out there. Okay, it includes those, but are there any others? Now there is another root out there. Does anybody know what it is? Okay, look at that. Nick.
3 plus square root of 5.
3 plus square root of 5. Because those are always in pairs. So if you got a 3 minus square root of 5, I got to have a root of 3 plus square root of 5. Now that's only with irrationals. And it'll also come up with complex numbers. But like the number 2, because 2 is a root doesn't mean negative 2 is a root. All right, now how do I go about this one? Now, the 2 is no problem. That should be a 5 there. The 2 is not the problem because you just make that x minus 2. Just make that x minus 2. You always subtract whatever the root is. So if it's a 2, you make it x minus 2. If it's a 4, you make it x minus 4. If it's a negative 5, you make it x minus negative 5, which becomes plus 5. Well, even though this is a binomial, we subtract it. Do x minus 3 plus square root of 5. Okay? And then subtract x minus 3 minus square root of 5. Okay? All right, Cole, what'd you do from here? How did you do it?
I started with the 2 factors with the radical in them because they were the most complex. Multiply those together.
Okay, there are multiple ways to multiply these two together. I'm just going to show you, I think, probably the most straightforward. Distribute the negative. Distribute the negative. Okay, and then just multiply like a trinomial, 2 trinomials. So take this x times all 3 of them. Takes this negative 3 times all 3 of them. And take that negative square root of 5 times all 3 of them. Okay? There's other ways that, I don't know, might be a tad easier, but I just think we're better off just doing it this way for now. So just multiply everything. Now don't forget there's still an x minus 2 here. We'll worry about that later. But I got x times x is x squared minus 3x. Cole, is this how you did it after that?
Yeah.
Plus x times square root of 5 is x squared root of 5. Move over to the negative 3. And then I'll multiply that by all 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And negative 3 times square root of 5 is minus 3 square root of 5. And now move over to that negative square root of 5. I'm running out of room, but I can cheat a little bit and move it over. And that gives me minus x square root of 5 plus 3 square root of 5, and then minus, all right, what's square root of 5 times square root of 5? 5. All right, take a look. What adds up to 0? Because when you do this, several things should add up to 0. Okay. So you got a positive, let's see here, x square root of 5 and I got a negative x squared root of 5. Those add up to 0. I got a negative 3 square root of 5 and a positive 3 square root of 5. Those add up to 0. Essentially, anything with a radical adds up to 0. What am I left with? I'm left with x squared. Negative 3x minus 3x is minus 6x. Plus 9 minus 5 gives me plus 4. And then I got x minus 2 still in front. All right, go ahead and multiply those together, and I'm going to hand out I wouldn't call them guided notes, but just somewhat similar to guided notes for the next little piece. Catherine, how you doing? Stop. You're done. Stop. We already know the roots. They're right there. All right, so when I multiply together, f of x equals, when I'm all done, x cubed. What's the rest of it, Cole?
Minus 8x squared plus 16x minus 8.
Okay, good. All right, read through Descartes' rule of signs and see if it makes absolutely any sense to you. So Descartes' rule of signs is at the top. Yep. All right, don't worry about the rules of balance at the bottom. Rules of balance. Ignore that. All right, now, honestly, to me, this made no sense the first time I went through it. It's really not overly difficult. It's just confusing when you first read it. Now, Descartes, Rene, of course, I'm sure what he did for a job, he had an awful lot of time on his hands. Okay, to come up with this. We're going to go over it. I'm going to show you what it is. Quite honestly, you probably won't use it. It's an option. But at least I have to show it to you. Okay. Now, reason it says we are trying to find additional ways to narrow the search for zeros. So like you list them all out with your B over A's, and this is giving you a way to say, all right, maybe I should try these before this group. It doesn't really tell you which ones to try, but it tries to narrow it down for you. So by this one, it's trying to tell you how many positive roots we could have, and how many negative roots we could have. A positive root is just anything that hits on the positive side of the axis. This has a positive number. These would be negative roots. This would be 2 negative roots, and this would be 3 positive roots. Okay, so it just kind of gives us an idea how many. Based upon whether the sign switches in the original equation. Does it go from a positive to a negative and a negative to a positive? Okay. That's called a variation of sign. Now, the way it's worded, okay, the number of positive zeros is either equal to the number of variations or less than that by a factor of 2. Okay, an even integer. So it can't be like 3 and 2. It could be 3 and 1, or it could be 4 and 2. It can't be numbers next to each other. For negative zeros, you have to look at f of negative x. I think the only real way to understand this is look at the example. Now, the example is there on your paper, okay? This is your function. It has to be in order from descending order from highest degree to lowest. And if it's not, you got to rearrange it, okay? All right, take a look for the possible zeros and any sign changes in the function. Well, anytime it goes from positive to negative is a variation. So right here, this is a positive x to the fifth. It goes to a minus. That's a variation, 1.
I need you real quick.
And then, yes. What, you paying for your AP test?
No, want me to teach the rest?
Do it.
No.
She was in 4 years was like
Stealing you.
She's like, come on, let's go.
Perfect timing.
She didn't ask. She's like, come on.
Let's go.
People at home are gonna be listening
Yeah,
to the recording.
They're gonna be like,
It's a brain.
So guys.
Yes.
Nothing.
All right, so how many variations? Now that goes from negative to negative stays, negative to positive, that's 2, that's 3. So how many possible positive zeros? It's either 3 or 1. So it's 3 or 1 positive. And here's the thing, it never just narrows it down all the way. It just gives you some options. So, like I said, you may use it, probably not. Because you're probably not going to go through the work for it. All right, f of negative x. You got to be careful here. You've got to plug in negative x wherever there's an x in the original function. Because that will change some of your signs. Again, no idea what led him to do this. None. But he somehow did. That's only going to change your signs if you have an odd power. Okay, and that's a power of 1. So then this now becomes, it was originally positive, it will become negative. This was cubed. Between those two, it now becomes a plus. This will stay a minus because x negative squared stays positive. And that'll switch signs. So how many variations do we have? We have 1, 2. The number of negative zeros, there will be 2 or 0. Can never be 1. Can't be 3. Okay, and we don't know. It's 2 or 0. So you're saying, well, how does this help me? Well, the only thing I would say is, well, there's a chance of 3 positive zeros, so I'm going to start with a positive number because there's probably more positive zeros than negative zeros. Okay, and then maybe I'll find one a little bit quicker. All right, we're going to kind of shut her down there. I do want you to go through just those. Okay, those are what things we did today. You do need to know these charts rule of signs. It will come up. I do expect you to know it. You may or may not use it when you actually solve a problem, but I want you to be aware of it.